Lesson 6 takes a look at the role of unlicensed frequencies in IBW solutions. It may surprise you to learn that in an industry as heavily regulated as wireless communications, there exist several commonly used technologies that use unlicensed, that is, unregulated, parts of the RF spectrum. Choosing to put part of your IBW solution on these unlicensed bands can be an economical way to extend coverage quickly, but they do come with some significant limitations. In a full IBW deployment, unlicensed bands still require a method of roaming agreement to connect with the licensed bands used by wireless operators. First, a bit of context. While standard Wi-Fi and DAS solutions have coexisted in larger enterprise spaces for many years, with the former serving data needs and the latter primarily supporting voice communications, the rapid rise in demand has taken all the spectrum these solutions were designed to give. Their once distinct frequencies of operation began to converge as each borrowed more and more unlicensed spectrum until they began to conflict with one another. Their functions too have begun to merge as solutions become faster and more efficient. Let's take a look at some of these unlicensed solutions now. One of the main advantages DAS holds over unlicensed solutions is the ability to interface with all kinds of wireless operator networks. Multiple technologies such as LTE, 3G and so forth, and virtually universal compatibility with wireless devices, making it a must for getting voice traffic on and off the core network. Voice over Wi-Fi, VO Wi-Fi, offers an unlicensed alternative that uses the IP network to route voice calls with acceptable quality. To use VO Wi-Fi, one must have a compatible device and the enterprise environment must be outfitted with Hotspot 2.0 coverage. Major manufacturers are introducing these wireless devices now, but the opportunities to use VO Wi-Fi on these devices remains hard to find. VO Wi-Fi deployments are few, but slowly growing, powered by next generation Hotspot 2.0. Hotspot 2.0 can essentially turn an indoor space into its own wireless operator. It can integrate with national wireless operators via a roaming agreement, just as national operators have with each other. While the technology is well established, these contractual roaming requirements have prevented Hotspot 2.0 from becoming a more frequently used solution for now. VO Wi-Fi does have significant limitations, however, many of which are common to all Wi-Fi applications, as we will discuss in greater detail in Lesson 7. A few of these limitations include potentially unreliable quality of service. Since VO Wi-Fi traffic may not be prioritized highly enough on the network, quality can suffer. This is particularly true in high traffic environments where users come and go. In these areas, user identification and policy application are challenging, possibly adversely affecting bandwidth. Adding sufficient access points to support users can reduce available throughput. As more access points are added to a Wi-Fi network, the amount of throughput at any given access point decreases. This introduces delays and jitter in voice calls. Calls drop at the door. While VO Wi-Fi can offer good connectivity within the enterprise space, it cannot smoothly hand off the call to the macro network when the caller leaves the covered space, and the call will drop. This is also true in reverse. The call cannot be handed off from the macro network to the VO Wi-Fi network when entering the covered space. Unlicensed frequencies mean you're on your own when it comes to interference. As we will explore in detail in the next lesson, shared spaces and multi-tenant buildings introduce the possibility of interference between neighboring Wi-Fi networks. Sometimes these can be resolved by informal agreements between the affected parties, but no established legal or regulatory recourse is available in cases of conflict. For these reasons, VO Wi-Fi is well suited to enterprises where there is a tight control over who uses it, where people spend most of their time indoors, and where one occupant fills the entire space. For other situations, there are other unlicensed solutions available that may be better suited to the circumstances. LTE unlicensed bands, LTEU, operate a bit like the ride-sharing services of wireless communications. LTEU uses LTE-style signal in the unlicensed 5 GHz band, the same band used by advanced Wi-Fi networks, to carry data and to a lesser extent voice traffic. However, like a ride-share, it's also subject to traffic jams because it shares frequencies with data traffic. Depending on the deployment, either voice or data may be bottlenecked. In some cases, LTEU specification allows the voice traffic to take control of the frequencies regardless of what other traffic may be trying to cross the network at the same time. Where it is aggregated through License Assisted Access, LAA, a listen before talk scheme checks to see if the frequency is clear before proceeding to connect. This arrangement is becoming the global standard. In some countries, it is a regulatory requirement. In either instance, however, a certain kind of traffic is allowed at the expense of another. LAA is a formally standardized way for an operator to add data on unlicensed bands to an existing LTE band. For IBW solutions, this means a local integration of LTE and Wi-Fi infrastructure to carry data and voice over parallel systems with similar speed and latency. The realities of business have driven an incredible amount of innovation in the use of unlicensed bands to provide indoor connectivity. Affordable and easy to deploy unlicensed band IBW solutions like VO Wi-Fi and LTEU offer an effective way to economize budgets, both financial and spectral. However, the inherent limitations of operating in unlicensed bands mean that, for the most enterprise environments, these solutions alone are not enough to provide high performance, high reliability, high quality service connectivity throughout the space. For the moment, a licensed band IBW solution is also needed to move this traffic on and off the operator's core networks. In the next lesson, we will take a closer look at the complex partnership between IBW and Wi-Fi networks to see how coexistence is not only possible, but profitable.